Hey everyone, welcome back. In today's video, we're diving into why sometimes the best code is, well, kind of boring. When we say boring code, we're not talking about something that puts you to sleep. In fact, it's quite the opposite. Boring code is straightforward, easy to understand, and above all, maintainable. Let's define what we mean. Boring code often involves more lines, uses longer descriptive variable names, and follows standard conventions. On the other side, smart code, often a term affectionately used to describe clever or less straightforward solutions, might use advanced language features, shorter variables, and less obvious approaches to solve problems. For example, let's say we're writing a program that reads a CSV, or comma-separated value file, and prints its contents. Here I have a CSV of 10 people with their names, ages, occupation, and the city that they live in. And here's the code that I've written to print these out. When I run it, this is the output. We have a list of each contact listed out in an easy-to-read format. What isn't easy to read, however, is the code, at least upon first glance. Just skimming over this, we can already tell we're splitting each new line into an array, grabbing each item after the first index, splitting each item again by comma, and iterating over these items, printing these seemingly random indices from each. While we could figure out what this function does after some time, there's a lot of extra thinking we need to do before it's revealed what this program actually does. Now let's rewrite this into its boring format. Taking a look at this code, things become a lot more clear. Immediately we can tell just by looking at the functions and variable names what's going on here. We're reading the contents of a file, extracting the individual lines, and converting each line into a list of contact information. What's also helpful about this method is we can decide how deep into the logic we want to traverse. We see here that there's a function called getContactInfoFromLine, which we can explore if we want to, but maybe we're only concerned about how each contact is printed, in which case we can explore the printContacts function. While it's true that the boring code is longer, it's a lot faster to read and understand than its shorter counterpart. While the benefits may not seem as obvious now, readable, maintainable code becomes extremely important when you're working on a project with hundreds, even thousands of files in it. Think of your code like a machine in a factory. The easier it is to understand how the machine works, the easier it is to fix or improve it without breaking something else. That's why maintainability is such a big deal. Now, it's important to understand that boring code doesn't mean avoiding more advanced language features in their entirety. In fact, by avoiding built-in abstractions and patterns, you may be making your code harder to read and understand. Take the following example. We have an array of objects named people. Each object has a name, age, and a list of cities that they've lived in. We want to write a function called getYoungAdults that gets the names of all the people under the age of 30 and the cities that they've lived in an easy-to-print format. One way to do this is to iterate through each person and check if they're under the age of 30. If so, then we loop through the cities that they've lived in and construct a comma-separated string. We then add this result to a young_adults array and return the result. Running this program, we get the following output. Alice has lived in New York, Charlie has lived in Boston, Chicago, San Francisco. While the logic here is simple and pretty easy to understand, we can make it better by using JavaScript's built-in filter and map functions. I won't go too much into the details of how these work, as that's not today's topic, but at a high level, filter loops through each item in the array, calls a custom function, and if that function returns true, the item is kept. Otherwise, it's removed from the array. Map works similarly in that it calls a custom function, but it replaces the current item with whatever your custom function returns. In other words, you're mapping each item in the array to a different one. In this case, we start by filtering out all the people under the age of 30, so we're only left with Alice and Charlie. We then map these people to a string. The string starts with person's name has lived in list of cities separated by comma. We use the join function, which takes each item in an array and separates it by a custom string. In this case, a comma with a space. When we call this function, we get the same output as before. Now, if you've never worked with filter, map, or join before, this function may seem more confusing than the first one we looked at, but that isn't necessarily a bad thing. Once you've learned how filter, map, and join work, this function becomes a lot easier to understand. And if there's one thing this exercise has demonstrated, it's that there's never a one-size-fits-all solution when it comes to engineering. Engineering, alongside many other fields, is a balancing act, oftentimes between time, maintainability, and performance. Software engineering is just as much a creative process as it is a technical one, and it's important to reflect on your goals before you start to write your code. Are you creating a script you'll run one time to process a text file? It's probably okay if your code is a bit of a mess, as long as it works. Are you working on a complex project used by multiple people that will likely stick around for a while? If so, you should probably plan it out in a document or a diagram and work on ensuring your code is easy to understand and maintainable. So, with all this in mind, how can you start to write more boring code? Use clear naming conventions. A great engineer once told me, characters on your keyboard are free, so don't be afraid of being descriptive. Stick to standard programming practices. If you don't have to reinvent the wheel, don't. Google around to see if there's an existing abstraction or pattern that you can implement to make things easier to understand. Avoid unnecessary complexity. Sometimes it's inevitable that the code is going to be complex or confusing. Writing a game engine, operating system, or working on sending a rocket to the moon, the code will probably be hard to understand. Otherwise, though, try and keep it simple to wrap your brain around. Write code as if the next person to read it is not familiar with it. Try putting yourself in someone else's shoes. If you were to look at this code for the first time, is it easy to understand? Or do you need to spend a lot of time deciphering each line? Comment wisely. Try not to explain what, but why something is done. Code with tons of comments can oftentimes be fixed with descriptive variable names and short, explicit functions. And there you have it. Embracing the art of boring code can lead to better, more maintainable software. What are your thoughts? Have you been burned by complex code in the past? What boring code have you personally experienced? And whatever your experience is, I appreciate you watching. If you liked this video, hit that subscribe button, and I'll see you next time. Bye!